So, good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, welcome class 9 students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing last chapter is refraction of light. Today we are entering into the session number 3. So far we completed 2 classes in understanding what is the refraction of light, what are the different ways refraction takes place, what are the main factors influencing the refraction of light, right? As you all know, the refraction of light is the property of light. Actually, it is a property, just like a reflection we have seen in lower classes. It is a property of light. So why it happens? Why it happens means when it changes from one medium to another. Changes from one medium to another. Right. So what happens? Speed increases due to change in the speed. Speed changes. So due to change in the speed, there is a bending of light takes place. Such a property of bending of light when it passes from one medium to another is called refraction of light. So there are 2 optical mediums may be there. It may one is but medium must be transparent. Only transparent medium can be shown the refraction property because the medium should allow the light to pass through. If it cannot allow, we cannot see the refraction. Like we cannot see refraction in opaque medium. Opaque medium, light will undergo reflection. But in the transparent medium, it will undergo refraction. Okay. So there are 3 possibilities. Whenever light passes from denser to rarer or rarer to denser, based on that, light may bend towards the normal or away from the normal. But whenever light passes straight along the normal incident ray, then there won't be any bending of light. There won't be any refraction. Angle is 0. So there are 3 possible cases where we can see the bending of light either towards normal or away from normal. That purely depends on whether the speed of light is increasing or decreasing when it passes from one medium to another medium. Such property of bending of light when it passes from one medium to another medium is called refraction of light, right? So already we have seen refractive index also. Refractive index, the speed of, for example, speed of light in vacuum is constant. With respect to that, we can find the speed of light in any other medium. So the ratio is called refractive index of that particular medium. Okay, that we discussed in the last class. We have seen some video also. So this is the first part. One case light is bending towards, other case light is bending away from the normal. Okay, so when it is the refractive index here, we have a lot of the values. What is the value of refractive index of the so many materials are given, that is denoted by mu. Mu, refractive index is another mu. That is given by the speed of light in medium by speed of light in second medium. First medium and second medium. And like that, if you take, finally you get the refractive index in nothing but speed of light in air by speed of light in medium, which is also called as absolute refractive index. So when there are 2 mediums are there, the ratio of speeds V1 by V2 is known as refractive index. If it is in case of air, and vacuum or air and other medium relative, say, that is called relative refractive index or absolute refractive index. We can see the values here. So refractive index of air, yes, you can have so many things are there: water, kerosene, quartz. So refractors are slightly changing, which are always above the 1 only. It's not less than 1. It is always greater than 1. The least is for air, maximum for diamond. Okay. Now, laws of refraction. So after observing the property of refraction, we can come to conclusion. Just like laws of refraction we have seen. Laws of reflection. Angle of incident is equal to angle of reflection. All the incident ray, refracted ray, and normal lights on same plane. Okay. Similarly, after studying the three cases of refraction, we come to one conclusion as laws of refraction. So the following are the laws of refraction. First one, the incident ray, the refracted ray, and normal to the interface of the two media at the point of incident, all the rays are same plane. Same like, for example, if you see this is a picture for the refraction. Suppose this is the water. This is A. So this is a normal. This is the incident ray, right? Incident ray. After it bends like this, refracted ray. Angle of incident, angle of refraction. So these three are all lying on same plane only. Incident ray, sorry, this side. Incident ray, refracted ray, and normal lying on same plane. So that's what. Second one, the ratio of sine angle of incident ray, sin I by sin R. Very important formula this is. Sine angle, you know, it's a trigonometric. Okay, sin I by sin R is nothing but it's called Snell's law, very famous law in light. And sine angle of incident, the sine angle of refraction. See, in case when light comes from air to water, that is rarer to denser medium, the light bends towards. When it bends towards, the angle I is greater than angle R. Right? So angle I is greater than angle R means numerator is more than denominator. So we'll get 1 plus only. But whenever the incident ray comes from the water to air or denser to rarer, it moves away. Then incident angle is less than the refracted angle. So different cases you can see. So sin I by sin R is always constant. Whether sin I may be increasing. So for example, here sin I is more compared to sin R. In second case, sin I is less than sin R. But the ratio is always constant. That ratio is called Snell's law. The value of constant is called refractive index. Also mu. You can denote it by mu is equal to sin I by sin R. Try to understand here. Two cases to study. First case, rarer medium to denser medium, air to water. So when it comes from air, when the light is coming from air and incident on water, the angle of incident is more than angle of reflection because light reflects towards the normal, bends towards normal. So angle I is more than angle R. But in second case, angle I is less than angle R. But ratio, if you see, maybe angle I increases, angle R decreases, or angle I decreases, angle R increases, but the ratio is always remains constant. That constant value is known as refractive index of that second medium where the light is entering with respect to first. Second medium with respect to first. This is also called as Snell's law, popularly known as Snell's law. Okay, so before going for the further explanation, we'll go for the one video on the same video explanation. Then we'll move to the topic again, right?
Happens when light is incident on the surface of a transparent object?
Transparent.
Consider a glass slab and suppose the narrow beam of light is incident on one side. The beam of light partially reflects, partially refracts, and is even partially absorbed by the object. In the past, we have already discussed laws of reflection. Do you remember those laws? The first one says that the light ray which is incident is reflected in such a way that the angle of incidence and the angle of reflection are equal. And the second one says that the incident ray, the reflected ray, and the normal all lie in the same plane.
This is for reflection problem.
Just like for reflection, there are some laws for refraction.
Just know what we have seen.
And what is refraction? Refraction is the change in direction of light as it passes across the boundary separating two media caused by its change in speed. If the refracted medium is optically denser compared to incident medium, then the refracted ray will bend towards the normal. And if it's optically rarer, it will bend away from the normal. Note that the light is incident obliquely on the surface. When the incident light is perpendicular to the surface, it does not change its direction. There are two laws of refraction. Among them, the first one is same as the second law of reflection. Consider light traveling from some medium 1 to another medium 2, which is optically denser than medium 1. So its speed in medium 2 decreases and it bends towards the normal. The first law of refraction says that the incident ray, refracted ray and the normal at the point of incidence all lie in the same plane. It means that if I were to draw this on a piece of paper, they all will be on the plane of paper and not out of the paper. What about the second law? The second law is also called Snell's law of refraction.
That is sin I by sin r.
Snell's law gives us the relation between the incident and refraction angles and the refractive indices of the mediums. What is the refractive index of a medium? It is the extent to which the refractive medium increases or decreases the speed of light. Mathematically, it is the ratio of the speed of light in the incident medium to the speed of light in the refractive medium. It's denoted by n, and the two numbers in the base are the two mediums. We read this as refractive index of medium 2 with respect to the incident medium 1. Also, V1 and V2 are speeds of light in medium 1 and 2 respectively. We can also define it as the extent to which light changes its direction in the refractive medium. Okay, let's discuss the Snell's law of refraction now. In simple words, it tells us that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is equal to the refractive index of the second medium with respect to the first medium. Now look at the term on the right. It is constant for light of a given color and for the given pair of media. This is the basic idea of Snell's law, and there are different ways in which we can understand it. In the previous video, we'd seen what n/1 means. It is equal to the ratio of speed of light in the incident medium to the speed of light in the refractive medium. So we can also say that sin I over sin r is V1 over V2. There's yet another way to understand this. We may want to understand the ratio in terms of the absolute refractive indices of the medium. Absolute refractive index, if you remember.
See, all the values what we are given in the textbook. Total as it is almost given. Some new also given here, right?
Is the refractive index of a medium with respect to vacuum. For instance, if the refractive medium is water, then it's written like this. So can we find this ratio in terms of N1 and N2? Yes, we can. We just use some very basic math. We can write this ratio like this, where C is the speed of light in vacuum. Yes, if you simplify this ratio, we will get V1 over V2. And can you guess what the numerator and the denominator are equal to? That's right. This is nothing but the absolute refractive index of medium 2, and this is the absolute refractive index of medium 1. That was another way of understanding the Snell's law. We can also say that sin I over sin r is N2 over N1, where N2 and N1 are the absolute refractive indices of media 2 and 1 respectively. Hope you understood this well. Let's move on to a new page.
Right.
So these were the two laws of refraction of light.
So, laws of reflection are these, refraction. There are two laws here. One is the incident ray, refracted ray and normal lie on the same plane. And second one is the ratio of sine angle of incident to the sine angle of refraction is equal to the speed of their lights as well as the ratios of refractive indexes. Okay. So these are called laws of refraction. What is that? We learned. That is today's topic. So one more small video is there to complete that before going for the further explanation.
Variables affect the amount that light refracts at the boundary, and how can you mathematically predict the angle of refraction? I'm Mr. H. Let's get started. When light crosses the boundary between two different materials, there will be a change in speed, a change in wavelength, and a change in direction. This change in direction is what we refer to as refraction. As an example, consider a boundary between air and glass, and let's suppose that the light is within the air, approaching the boundary. This is referred to as the incident ray. At the point of incidence between this light ray and the boundary, we can construct a normal line, a line drawn perpendicular to the surface. And once we do, the angle between the normal line and the incident ray can be measured. This is the angle of incidence. Because light refracts at the boundary, it won't travel along a straight line path, but instead will bend either towards or away from the normal line. For the case of air traveling into glass, the bending will be towards the normal line, and the refracted ray will be located in this region. The angle measured between the normal line and the refracted ray is known as the angle of refraction. Because light is bent at the boundary, the angle of refraction will not be equal to the angle of incidence, and the more refraction that takes place, the greater the difference between the angle of refraction and the angle of incidence.
सो हे गाइस व्हाट्स अप, आज के इस वीडियो में हम लोग बात करने वाले हैं इन्वर्टर एलिमेंट्स, क्या आपको मिलने वाला है, कैसे आप उसे यूज़ करोगे, क्या क्या चीज़ें हैं, मैं आपको लाइव दिखाने वाला हूँ। ठीक है, अब क्या होने वाला।
The amount of refraction that occurs at the boundary depends upon two variables, the angle of incidence and the materials located on opposite sides of the boundary. When light approaches the boundary while traveling along the normal line, the angle of incidence is 0 degrees and there is no refraction whatsoever. But as the angles of incidence are increased from 0 degrees to larger and larger values, the amount of refraction increases dramatically. The amount of refraction also depends upon the materials on opposite sides of the boundary. Here we see light passing from air into water, into glass, and into diamond. The angle of incidence is 45 degrees in each of these three situations, and the index of refraction of the starting material, air, is 1.00 in each of the three situations. What's different about these three cases is the index of refraction of the material into which light is passing. In the case of light passing from air into water, the incident ray will bend, and the light will be located 13 degrees closer to the normal line than the incident ray was, making the angle of refraction 32 degrees. But when light passes from air into glass, the amount of refraction is 17 degrees, placing the angle of refraction at 28 degrees. And in the case of light passing from air into diamond, the amount of refraction is 28 degrees, making the angle of refraction 17 degrees. This data provides evidence to support the claim that the amount of refraction that takes place at the boundary depends upon the difference in the index of refraction of the two materials. A common physics lab involves the use of a hemicylindrical dish of water. Laser light is directed towards the midpoint of the flat side of that dish of water. The light refracts towards the normal line and enters into the water. It exits the curved side while traveling along the normal line at that surface and does not undergo refraction. The angle of incidence in the air and the angle of refraction in the glass can be measured, and a data set can be collected that would look something like this. The experiment is then often repeated, but without the dish of water. Instead, the water is replaced with a hemicylindrical disc of lucite glass. If the data for both of these experiments is plotted as the angle of incidence versus the angle of refraction, we would observe that the line is relatively straight for the smaller angles of incidence, but then begins to curve more and more for larger and larger angles of incidence. But if the sine of the angle of incidence versus the sine of the angle of refraction is plotted for both of these experiments, we get straight lines. The slope of the line can be computed. It comes out to be about 1.33 for the air to water boundary and about 1.50 for the air to glass boundary. The y-intercept is 0 in both of these situations. We can use y equal mx plus b to write an equation for the lines on these graphs. For air to water, the equation would be sine of the angle in air is equal to 1.33 times the sine of the angle in water. And for the air to glass boundary, the equation would be the sine of the angle in air is equal to about 1.50 times the sine of the angle in glass. As is the case in science, we would like to generalize from the experimental findings found under certain conditions to a more general conclusion that works for all conditions. So for the condition of light traveling from air into water, we can make the observation that the 1.33 and the 1.00 in the equation are the index of refraction of air and of water. And for the condition of light traveling from air into glass, we can make the observation that the 1.50 and the 1.00 in the equation are the index of refractions of air and of glass. So this leads to a more general conclusion, a law of refraction, known as Snell's law, that can be stated in equation form that looks like this. N1 times the sine of theta 1 is equal to N2 times the sine of theta 2. In this general equation, the N values, N1 and N2, represent the index of refraction of the two materials on opposite sides of the boundary. And the theta values, theta 1 and theta 2, are the angles of incidence and the angles of refraction as measured with respect to the normal line. This is known as the Snell's law equation. In a typical physics course, the Snell's law equation is often used to solve physics word problems in which you must predict the angle of refraction. Here is an effective strategy for approaching such problems. First, read the problem carefully and identify and record the known values. Snell's law equation has 4 variables in it, so you'll need to know 3 values in order to solve for the 4th. Express your known values in terms of the symbols of the equation as shown here. Second, identify the unknown value in the problem, like theta r equal question mark. Third, construct a diagram in order to help visualize the situation. A ray diagram works fine. Notice how in my ray diagram I've recorded the known values on the diagram. Fourth, substitute the known values into the Snell's law equation and then perform proper algebraic manipulations in order to solve for the unknown value. And then finally, ask yourself, is my calculated answer reasonable? For light traveling from a material with a small index of refraction to a material with a larger index of refraction, the light will bend towards the normal line, and the angle of refraction should be less than the angle of incidence. The opposite is true for light traveling from a material with a large index of refraction to a material with a small index of refraction. Use this understanding to check if your answer is reasonable. This is the first of 2 example problems in which I show how to use that 5-step strategy to solve a physics word problem.
Anyway,
I begin by reading the problem carefully and identify the known.
Completely about what is the refractive index and what is the. So what we learned so far is explained completely in the video. So first we learn about what is refraction, what are the factors influencing refraction, why is refraction, how is refraction, then what are the possible 3 types of refraction. Then we enter into the what is the refractive index. Then we enter into the what are the Snell's law, angle of incidence in terms of angle. So next, when you come to the synopsis 3, in next class, we discuss about the what is the refraction when it passes through the glass slab. When light passes through glass slab, and when glass passes through refractive prism. So many examples are given here. So how the formula changes, the Snell's law changes. There are various examples are given here. Path of the light, when you place different object in the path of the light, what kind of effect you can see here. Okay. So how the light disperses into colors, that is formation of rainbow. All these things comes under this category, refraction only. Right. All these are the comes under the refraction, which we'll cover in the coming classes. Okay. So what we learned so far, if we discuss, we'll just recall. You can mention as a synopsis also, you can mention what we learned so far before going for everything. If you see here, and you note down the notebook like synopsis, all of you. The first point is bending of light. Bending of light when passes from one medium to another, called refraction of light. Point number one, right? So bending of light when it passes from one medium to another is called bending of, that is called refraction of light. That is the first synopsis what we learn. Next one is, so light, why light bend? Light bends at the boundary of mediums, won't bend throughout, at the boundary of mediums due to change in speed. Change in speed. Why they are bending? The question for why is, the second one is why. Why refraction takes place? Because change in speed. Right? Because of change of speed, when light moves from one medium to another, to change the speed. Because speed of light is different in different mediums. This is constant in vacuum, but change different mediums. That is the reason light will bends. The answer why light bends. The second one is how. Third one, sorry, how light bends. Right. So depends. So light bends either towards or away. Towards or away from normal drawn at point of incident. Point of incident. Right. So how light is bending? So light bends either towards or away. Away from the normal, drawn from at the point of incident. Where the light is incidenting, there only we are drawing the perpendicular line, which is called the normal. Fourth one, that is refractive index, that is speed of light. Speed of light in medium 1 by medium 2. That is equal to V1 by V2 is called refractive index denoted by mu or n, anything. Speed of light in medium 1 by speed of light in medium 2. Right. So when you come to point number 5, again that is Snell's law about angle. This is, that is angle of sine angle of incident by ratio of sine angle of refraction, which is called Snell's law. Angle this is. That also depends on the speed only. When speed is more in second medium, angle of refraction is more because light moves away from normal. The speed of second medium is less, it will move slow and moves towards the normal, like that. So based on that, we can define the Snell's law. The ratio of angle of incidence to the angle of refraction is also one of the important law of refraction. So similar to law of reflection also says that incident ray, refracted ray, and normal lies on a same plane. So this and fifth and sixth are called law of refraction. Let's sixth one. So incident ray, refracted ray, and normal lies on same plane. So sixth and fifth point, they together called as laws of refraction. Laws of refraction. Right. So these are the points what we discussed so far. When you move forward, we'll go how light passes, how the refraction takes place. When light passes through plain glass slab, or when light passes through the prism, and when light passes the multiple glasses. So many ways you can discuss about the refraction. When you go to higher classes, you can learn more and more in the 12th class, especially after 10th, 12th. Clear? So 6 points totally we learned, which clearly gives about the complete idea what we learned so far in this chapter. So again, we are going to learn so many things, synopsis 3 and 4. And in the next class, if any possibilities after the FA4 exams. Okay. So that's all for today. You practice well. The levels also in that, or go through the concepts. And thank you very much, all of you. Have a wonderful day. Thank you.